Hey, Chem team. So if a chemist wants to plan out a reaction, they'll have to rely on ratios between atoms and molecules in a process called stoichiometry. So for example, if a chemist wanted to create beryllium fluoride and they had 18 atomic mass units of beryllium, they'd need to know how much fluorine to measure out in order to react with the beryllium. And this is a pretty common problem that chemists face. Since chemists can't see or count atoms individually, they have to determine how much of an element or compound they have by weighing it. So to figure this problem out, chemists would use a series of ratios to relate our starting variable, this mass of beryllium, to the mass of fluorine. So for instance, a chemist, by looking at the periodic table, could know that for every 9 atomic mass units of beryllium that they would have 1 beryllium atom. And they can use this to convert their mass of the beryllium atoms into the number of beryllium atoms they have. Furthermore, by drawing out a Lewis structure for beryllium fluoride, they would know that for every beryllium atom that they have, they would need 2 fluorine atoms. And so they can convert their number of beryllium atoms into the number of fluorine atoms that they need. By looking at the periodic table, they can know that for every fluorine atom that they need, it will weigh 19 atomic mass units. And so they can convert the number of fluorine atoms that they'd need into the mass of fluorine that they would need. And so to do this, they would use a conversion table. They'd start with 18 atomic mass units of beryllium, and then they would use these ratios to convert the mass of beryllium into the number of beryllium atoms. Then to convert the number of beryllium atoms into the number of fluorine atoms, and last to convert the number of fluorine atoms into the mass of fluorine atoms. And so as they're doing that, they would be sure to put the same units in the denominator as the starting variable, so as to shift the focus from one unit to the other. And then the process would repeat itself. So initially we would switch from the mass of beryllium to the number of beryllium atoms. But then we would switch from the number of beryllium atoms to the number of fluorine atoms. And last we would switch from the number of fluorine atoms to the mass of fluorine. Then by multiplying across our numerators and dividing by our denominators, we would see that the mass of fluorine that we would need to react with 18 atomic mass units of beryllium is 76 atomic mass units of fluorine. And that's it. At this point, you guys have a couple of practice problems. We'll see you in class tomorrow.